First of all, read the question corresponding to there are two systems. So in your screen, according to question, consider two power systems shown in figure below, which are initially not interconnected and are operating in a steady state at the same frequency. Separate load flow solution are computing individually for two systems corresponding to this scenario. The bus voltage phasors so obtained are indicating on figure. These two isolated systems are now interconnected by a short transmission line. As shown in figure, it is found that P1 this equal to P2, this equal to Q1, this equal to Q2, this equal to 0. Okay, the bus voltage phase angular difference between generator bus X and generator bus Y after the interconnection is 10 degree, 25 degree, minus 30 degree or 30 degree. Okay, clear? So it is clear there are two isolated system. This is, if this one is S1, if you consider this isolated system is S1 and this isolated system is S2. Clear? Both are isolated system, are in before interconnection, both are operating same frequency. If first one operating F1, if F1 this S1 is operating corresponding to 50 Hz, this one is also operating 50 Hz because of according to question given same frequency. Okay, now at a steady state, now after interconnection, if both are interconnect with short transmission line like this one, then what about power? P1 Q1 it's sending in and receiving P2 Q2. Okay, now our motto according to question P1 Q1 this equal to P2 Q2 this equal to 0. So it means according to question P1 this equal to P2 this equal to Q1 this equal to Q2 this equal to 0. Okay, according to question given here. Now I know that for a short transmission line, okay, that is short transmission line, that is P1, here voltage that is Vs and that is Vr. If Vr at the angle 0 degree and Vs this equal to Vs at the angle delta and that is Jx. I have already discussed for receiving power PR is equal to Vs Vr into sine delta divided by x. Okay, now if this one is not 0, this one is not 0 and this one is not 0 and this one is 0, then it means sine delta this equal to 0. So what about delta? It means 0. It means sending in and receiving voltage angle is same. Clear? That is possible only when both voltage, both phase angle are same. Then what about P2 or you can say receiving power is 0. Clear? So P2 is 0. Why? Because of delta is 0. Okay, phase angle is 0. Voltage phase angle sending in and receiving in. Now another way, what about QR? I have already discussed Vs Vr divided by x into cos delta minus Vr square divided by x. Okay, now QR here Q2 or Q2 is 0. If Q2 is 0, it means this one is not 0, 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 this one is not 0 and this one cos delta is 1. So you can written here Vs into Vr. If Vr is common, then Vs minus Vr this is equal to 0. Okay, if this one is not 0, then it is possible only Vs this is equal to Vr. It means magnitude wise sending in voltage this is equal to receiving in. Okay, what is the conclusion? P2 V2 is 0 when P2 and Q2 is 0. If P2 and Q2 is 0, it means Vs and Vr are same for magnitude wise and also phase angle, and angle wise are same. Okay, and if delta S and delta R that is 0, or you can say that same. That's why delta is delta S minus delta R is 0. Clear or not? What is the conclusion? P2 Q2 is 0 when only if sending in voltage and receiving in voltage are same for magnitude wise and angle wise. Okay, sending in voltage and sending in magnitude wise, sending in voltage and receiving in voltage are same, and what about angle, phase angle of sending in and receiving in, both are same. Clear? It means clear. So what is our conclusion after this scenario? You can say that sending in voltage is equal to receiving in voltage. Okay, so V at the angle delta, whatever according we have here got delta is 0, so you can say that is taken reference. Okay, and what about V? That is phase angle is 1 1, magnitude is 1 1, so you can say that it is written as 1 at the angle 0 degree. Clear or not? Okay, now next target is our motto: determine phase angle. Phase angle difference between bus X and generator bus X and generator bus Y. Clear? Now if you here given this angle, if 1 at the angle 0, 1.02 at the angle 0, then what about that angle, that is minus 20. Okay, means reference here. According to this system, if take reference, then you got voltage like this one, and here if taken reference here, then we have talked voltage corresponding to that point is 1 at the angle minus 5 degree. Clear or not? If reference is changed, reference we have taken 1 at the angle 0. If 1 at the angle 0 reference, it means if only possible if here adding my plus 20, it means if you adding plus 20 here also, 20 adding here also, it means final after interconnection, if 1 at the angle 0 we have taken corresponding to condition 1 at the angle 0, then what about angle, what about what bus voltage corresponding that generator, that is plus 20, and here 1.02 at the angle plus 30 degree. Clear? Now here if that is minus 5 degree, if you want to 0 degree here, it means 1 at the angle 0, then possible only if 5 angle is adding in all scenario. Okay, it means 1.02 at the angle 5 degree, and here 1.02 at the angle plus 20 degree. Okay, after adding clear or not? According to question, so sending in voltage and receiving in magnitude wise same and phase angle wise is same. Okay, if you take 0 angle, it means only possible if here adding 20 degree. Okay, because we got 0 degree, then only possible if 20 degree adding here, then also phase angle adding here 20, here 20. So finally we got, if take reference that if this bus is taken reference, then we have got voltage 1.02 at the angle 20 degree, and here this voltage is changed 1.02 at the angle plus 30 degree. Our motto same thing here also, because we got 0 degree only possible if 5 degree added in all voltage phase angle. Okay, so after that our motto phase difference between X and Y, then we got 30 minus 20, so that is 10 degree is the final answer. Make it.